Hey kiddos, here's the spiral feedback video. This is for the feedback sections on spiral 10. First off, we got systems of equations. This was definitely a trouble part for us on the spiral, and it looked like a lot of not really knowing where to begin or not trying. The second one I can't help with, the first one I might be able to. I tried to give you some additional feedback on the bottom about where you were and what type of help you might need. So if you're getting some of the way there, you probably can do work with these videos and be okay. If you're completely lost, yeah, you really do need to take kind of the responsibility for it and start coming for help either before or after school. For the first one, I noticed that these are both lined up there in what we call standard form, and I'm going to use elimination as a method. When I look at this, I see that my x's, I can make the same coefficient very quickly. If I multiply the top by 3, I'm going to do a trick and multiply this by negative 3, so that when I do that, we get negative 3x minus 9y, and that was actually one of the things that was most commonly wrong on your spirals, and plus 33. So one of the mistakes I saw a lot here was saying negative 3 or 3, depending on how you did this, times 3 was 15. Which I think you just kind of saw the 5 on the bottom, multiplied by that instead. The second thing that went on here is some adding or subtracting errors. That's why I multiply this by negative, so I can add. Subtracting, we're more likely to make some mistakes. So if I get 3x minus 3x would be 0. 5y minus 9y, because that's adding negative 9y, is negative 4y. And negative 21 plus 33 is going to be positive 12. That means that when I divide by negative 4, we get y is equal to negative 3. I can plug this back into the original equation. This didn't seem to be something that we had an issue with. Sorry, it should be x plus 3 times, instead of y, negative 3 is equal to negative 11. So if we've got x minus 9 is equal to negative 11, that's going to be x is equal to negative 2. So my solution here was negative 2 and negative 3. Elimination was the easiest way to do this and perhaps the fastest. In general, I saw some people try substitution, and that was okay. The first part for this might have been to rewrite this as x is equal to negative 11 minus 3y, and then substitute that in here. 3 times negative 11. I don't want that. I'm going to erase that parenthesis so it doesn't get confusing. Minus 3y is equal to negative, I even forgot my second part, plus 5y, there we go, is equal to negative 21. That would be negative 33 minus 9y plus 5y is equal to negative 21, and you can solve from there to get that same thing that we had using elimination. There's more likely to make some mistakes if you're using substitution. For the second problem here, a lot of us did okay with the first step, which was to identify that those two are equal, and to rewrite this as 3x squared minus 5x is equal to 2x squared plus 7x minus 27. And most of us kind of froze here. We didn't know what to do. The goal here is to get everything on one side. I said set equal to 0 on a whole bunch of spirals. What that means, I want to get one side of this equal to 0 so we can factor it. So I might do minus 2x squared minus 2x squared. I like keeping the x squared positive. And I'll have 1x squared. I might do minus 7x and minus 7x, and then I'll have minus 12x. And then I saw a lot of people get stuck here. It was like you got the x's on one side, then you didn't know what to do. The last piece of this is you'd actually add the 27 to both sides. And the reason for this is that you want this to be x squared minus 12x plus 27 is equal to 0. So that when you factor this, you get something that you can actually solve for. And two things that multiply to 27 and add up to negative 12 are going to be negative 9 and negative 3. So it's going to be x minus 9, x minus 3 is equal to 0. which means that x equals 9 and x is equal to 3. The last thing is we got to plug these back in to find what y is. I'm going to use the first one because there's less stuff there. And I'm going to say, for x equals 3, y equals 3 times 3 squared minus 5 times 3. That's 27. Minus 15 is going to be 12. I think the other one's going to be really big. And then for x equals 9, we got 3 times 9 squared minus 5 times 9. Well, 3 times 81 is 243. Minus 45 would be 198. So my y value would be 198 for x equals 9 and 12 for x equals 3. The next up we had the owl populations. We had some different stuff going on here. Most people who tried this problem ended up doing okay with the mouse part, but sometimes we had some variables messed up here. We don't know how many of each of these owls there are. So I'm going to call S is the number of snowy owls, and B is the number of barred owls. And as a treat for anyone who actually decides to look at the feedback video, this is the way that a snowy owl sounds when it is hooting. And this is what it sounds like if it's calling instead, like if it's in danger. Which is kind of creepy. And just to keep that going, one of my favorite animals is the barred owl because they sound like this. Which is awesome. They sound even cooler if they have a bunch of them getting together. If you get a bunch of them together, it sounds like a bunch of monkeys, which is kind of freaky if he wakes you up in the middle of the night. But if you ever hear noises like this and you're outside, this is from your local friends, the barred owl. And that's your ornithology lesson for the day. Back to the math. So we've got to deal with the mice, and we know that snowy owls eat an average of 3 per week. So most people did something like 3 times snowy owls, and barred owls eat 5 per week. So that would be 5 times the barred owls. And most people did something like 79 for that, which is correct. A lot of the trouble we saw is that we didn't know what to do with the 21 owls. And what this actually is, and for most of the problems that we look at for systems of equations, we're going to have some kind of a combination like this. Excuse me. Where 21 would be the total, and we're looking at the total number of snowy plus barred owls. Once we have this set up, this is really nicely set up for elimination. I can multiply this by -3 or -5 if I wanted, and I get -3s minus 3b is equal to -63. And that goes with my top equation, 3s plus 5b. I should not use s's as variables because that first s looks like a 5. And that's equal to 79. So when I add these together, I get 0, I get 2b, and I get -63. Plus 79 is going to be 16, which means that b is equal to 8. There are 8 barred owls in the woods, and you need to say that as well as you need to show the variables. Okay, so if there are 8 barred owls, I can use that snowy plus barred equals 21 to say that there are 13 snowy owls in the woods, and you also need to write that out. You need to tell me what these things mean and give me some context. Next up, we have properties of exponents and polynomial basics. This went actually pretty well. There were some common misconceptions that we'll talk about. The first is that these are all multiplication problems or division problems for the exponent ones. So there never should be a plus or a minus showing up in these. The second is that whenever we have exponents going on, Each of these are going to be treated separately with the numbers and the x's and the y's. So we're going to do the numbers first. That would be 3 times 7, which would be 21. The second part is the x's, x to the second times x to the third. That means that we are going to add these exponents. We multiply, we add the exponents. That would be x to the fifth. And the last is y to the seventh and y to the fourth. 7 plus 4 would be 11. That's actually the final answer for this problem. You can't do anything else there. For the second one, the first major thing we had going on was we saw 8 over 4. We know the rule for dividing is subtracting exponents, and we subtracted these. But really, we're dividing 8 divided by 4, and that would be 2. For the x's, we've got x to the 3 over x to the 7. 3 minus 7 would be negative 4. More on that in a second. And then 8 minus 3 for the y's would be 8 to the 5. Y to the 5. That's what happens if I write and talk about different things at the same time. So we'd be at most of the credit here. The one thing you got to be careful of is I don't want there to be negative exponents in there. So you could rewrite this as 1 over x to the positive 4. That's what a negative exponent does. It's a reciprocal. And then y to the 5. That would be full credit. The other thing that would be full credit is if you wrote these two things that are over 1 on top of the fraction. So 2y to the 5 over x to the 4. That's the cleanest looking of all of these possible answers. Number 13, the biggest mistake is not realizing that this is subtraction. And if you don't notice that this is subtraction, you try to distribute and you end up with a mess. But since it's subtraction, we are doing combination of like terms. 3x squared minus 5x squared, negative 7x minus negative 6x, and then we've got 11 minus 2. 3x squared minus 5x squared is negative 2x squared. Negative 7x minus negative 6x, so that's really plus 6x, is negative 1x. And 11 minus 2 is 9. So we've got negative 2x squared minus 1x plus 9 is our final answer. Biggest mistake after kind of the distribution thing was not seeing the double negative here and ending up with negative 13x instead of negative 1x. And finally, number 14, this one is distribution because we're looking at multiplication. And when we do that, we've got to distribute each piece to each piece. 2x times 3x squared is 6x to the third. 2x times minus 5x is minus 10x squared. And 2x times plus 2 is going to be plus 4x. Minus 3 times 3x squared is going to be minus 9x squared. I'm going to line that up under the other x squared piece. Minus 3 times plus 5x is going to be plus 15x. I'm going to line that up under the x piece. And minus 3 times 2 is minus 6. When I add these up, we've got 6x cubed minus 19x squared plus 19x and minus 6. And that's your final answer. The biggest mistakes I saw here were not multiplying correctly as far as getting exponents. I saw a lot of 6x to the fourth. And then I saw things being added together that weren't actually like terms. But in general, this page was pretty good. For the most part, we seem to be in better shape on this page, which is nice, since we're going to see this for another 3 weeks.